If I was to ask you, why do you think we tried nuclear power, what's your answer?
Because we're trying to find new ways to get power to fossil fuels.
Okay, number one, fossil fuels are running out. That's great. What else?
It's a lot cleaner.
It's a lot cleaner. They are looking for cleaner. Because if you're thinking why, you're thinking those two. All right, so we're looking for substitutes because fossil fuels are running out. We're looking to make it cleaner because of global warming and ozone. And that's really the two things. And always remember that they're also looking for ways to make more energy. So they want the same input with more output. If that makes any sense, I'll explain it later. So nuclear power, which by the way, if you look, here is a world map of nuclear power, and we use it. It's just like a fossil fuel. It's non-renewable. You don't have to know that whole sentence. Just know that it's non-renewable and that it's common in Earth's crust. So we mine for uranium, which is what it is. Uranium is the ore of the mineral. That means the profit of the mineral is uranium. And it's called uranium-235. That you do have to know. So back to my question before, why nuclear power? What you didn't mention about the output with one little pellet of uranium, that's what the uranium looks like. You get the same amount of electricity as a ton of coal or 3 barrels of oil or 1 cord. That means that's what they call the amount of wood, or 17,000 cubic feet of natural gas. So one little pellet will do the same job as a ton of coal. That's a huge, huge difference. A lot.
Is it dangerous?
Yes.
What about war?
That's one of the dangers. So yeah, and there's a lot more than that. This is who uses nuclear power in the United States, and if you notice, how many do we have?
Yeah, 3 and 4. 5.
They're 5.
5. And how many do we have in South Florida?
4.
You know, we have one in between Key Biscayne and the Keys. It's called Turkey Point. So we have one very, very close to home.
Are we powered by that?
And we are powered by that. FPL owns the nuclear power plant as well as the coal-powered plant. So nuclear power accounts for 19% of the total electricity production in the United States. So we rely heavily on nuclear power. Number 1 is what? For electricity. What's number 1 electricity producer?
Coal.
Coal. Number 2, nuclear and natural gas are kind of tied. For the US, not so much natural gas, but for the world, yeah, because people don't have access to other forms. And there's just another map of nuclear power. And you don't have to know this. Worldwide, there's about 435 generators in 33 countries. This is more geography, but you don't have to know the geography on the test. All right, this you do have to know. This is how nuclear power, that one little pellet, produces all these massive amounts of energy. So this is the diagram, and I'm gonna go over the diagram step by step. The first thing that happens is a neutron hits the uranium-235 atom. What do you think is gonna happen to it based on the picture?
Each time it splits, it creates more energy.
Okay, so when it hits it, it's gonna split. The U-235 splits, and all of this energy is released. It's not just gamma radiation, it's heat energy, so please put that in there. So you have a neutron hits a U-235, it splits it in half, and all of this heat energy is produced along with radiation. Besides the gamma and the heat, 3 or 2 more neutrons are produced. If you look at the diagram, these other neutrons kind of pop out of there. They're gonna go and hit another U-235, and they're gonna split that, causing what?
Because that's a split, and the one that's split from air is going to split other one.
So causing what? More what?
Energy.
More energy and more?
Split up.
More
Power.
power and more radiation. Okay, so you got all of this excessive amount. This is what we call an uncontrollable chain reaction. It just doesn't stop. I mean, from what I've read, it could go on for years. One pellet or one U-235 can produce so much, well, you saw, so much energy. And I'm going to stop there.